Everyone, this is E.M.F of EC department, second year, BTech in VVIT. We're going to learn about heatsink. Heatsink, it is a component or device in a circuit which disperses the heat from circuit, mainly from power transistors to surrounding components, and in turn by cooling them improves the performance and reliability of the circuit components, and also it avoids the premature issue of the circuit components. It is based on the principle of heat conduction of Fourier's law. It states that if the body has temperature gradient, the temperature will flow from high temperature region to low temperature region. Types of heat sinks. These are generally divided into many categories based on different criteria, but the major types are termed as active heatsink and passive heatsink. Active heatsink. These are generally fan type and can be also generally termed as heatsink or fans. These fans are further classified into two types: ball bearing type and sleeve bearing type. The performance of this kind of heat sinks is excellent, but these are not used for long-term applications. Passive heat sink. This does not possess any physical components like fans, like in the active heat sink, and these are made up of aluminum finned radiators. These dissipate heat by the process of convection, and these passive heat sinks are more reliable than active heat sinks and can be used for long-term applications. Aluminum heat sink. These heat sinks are generally made up of metals, and aluminum is the most commonly used metal in making of the heat sinks. And when the thermal capacity of the heat sink is increased, then the heat transferring capacity of that heat sink will also be increased. These are advantages. Stamped heat sink. These are made up of metals that are made to get the particular shape by the stamp process. Machining heat sinks. These are manufactured by the machining process. In machining heat sinks, gang saw is frequently used to cut to the piece of metal from a block of material. Bonded heat sink. This is made by the process of bonding individual lengths of metal to the base of the heat sink. And some of the other heat sinks are skewed heat sink, forged heat sink, etc. These are the type of heat sinks and its uses. We're going to learn about Faraday's law. Firstly, the equations governing electrostatics and magnetostatics are delta cross E equals 0, that is line integral of E dot dl equals to 0. Delta dot d equals to rho v, that is surface integral of d dot ds equals to volume integral of delta dot d of rho v d. Delta cross h equals to j, integral of line integral of h dot dl equals to surface integral of delta dot h of ds. Delta dot b equals to 0, that is surface integral of b dot ds equals to 0. The first two equations are for Maxwell's equations for electrostatics, and the second two equations are for Maxwell's equations for magnetostatics. Faraday's law. It proves the link between the magnetics and electrostatics. Oersted conducted experiments that the current carrying wire produced magnetic field as it has shown the deflection in the magnetic compass. He also demonstrated that if the magnetic field is in the phi direction, then the current will be in the z direction. So Maxwell has done his hypothesis on these experiments and has come to the conclusion that if the current carrying wire has produced a magnetic field, then the converse must also be true, that is, magnetic field can also produce the current in a wire. He done many experiments, and after a period of time of 10 years he has found that his statements are true, that is, the magnetic field will be magnetic field induced will produce a current in the wire only if there is a relative motion between them. The statement is the induced EMF in a closed circuit is equal to the rate of change of magnetic flux linkage by the circuit. Delta cross E equals to minus dou E by dou T. Transformer EMF. As the time varying AC voltage is applied at the input side of the transformer, the current is produced in the primary coil of the transformer. That current produces an induced EMF, which by the process of mutual induction, this EMF is linked to the secondary coil of transformer, and the secondary coil magnetic field induced will produce a amount of current that will be flowing throughout the secondary circuit, throughout the load or whatever the output we had connected. So it also proves that the time varying current also produced magnetic field, which in turn the magnetic field also produced current in a wire. This is the Faraday's law. Now we are going to learn about band pass process. A random process n of t is said to be band pass process if its PDS SNN of omega has significant components of frequency clustered in the band of width omega radicals per second. That does not include omega equals 0, but in practical SNN of 0 is not 0, but it can be small that it can be neglected. So the graph is like it is not touching the x-axis at omega equals to 0. Band limited process. If a random process and band pass process is said to be a band limited process if its power components are 0 outside the frequency range of band of width omega radicals per second and thus does not include omega equals to 0. Narrow band process. If band pass random process is said to be narrow band process when the frequency omega is very less compared to the band cluster frequency, that is omega is very less than omega naught. The narrow band process is frequency modulated and amplitude modulated function of cosine and has frequency omega naught in it. So the equation is n of t equals to amplitude a of t into cosine function cos of omega naught t, that is band cluster frequency, plus theta of t is the phase.